7.1 deals with ratios in similar polygons. So figures that are similar have the same shape, but not necessarily the same size. So this is the symbol for similar, this little squiggly line. So here, triangle 1 and triangle 2 have the same shape, even though they aren't the same size. So they're not congruent, but they're similar. So triangle 1 is similar to triangle 2. In this one, triangle 1 is not similar to 3 because they're not the same shape. Even though they're both triangles, this triangle, they're different triangles, I guess. This one's a right triangle, and triangle 1 is not a right triangle, so they're different. So they're not similar. So they need to be the same shape, just a different size, in order to be similar. So two polygons are similar polygons if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. So their angles need to be congruent and their sides need to be proportional in order for them to be similar polygons. So here we have two similar polygons because all their angles are congruent. So angle A corresponds to angle E, angle B corresponds to angle F, angle D corresponds to angle H. And the side lengths are proportional. So proportional meaning since this side AB corresponds to EF, we put the side length of AB, 6, over the side length of EF, which is 12. And we find out what proportion this is. So what does 6 over 12 simplify to? 1/2. If we did the same thing for this side AD, which corresponds to EH, and did 5 over 10, what would this simplify to? 1/2. So we can do the same thing for every single side, and our proportion is 1/2. So triangle ABCD is 1/2 the size of EFGH. So each side is going to have this proportion. Okay, so our first example, identify the pairs of congruent angles and corresponding sides. So let's identify the pairs of congruent angles first. So which angle is congruent to which angle? Let's start with our big triangle. What is angle N congruent to?
Angle Q.
Angle Q, perfect, because they're both 90. What is angle M congruent to?
T.
Angle T, perfect. And what is angle P congruent to?
Angle R.
Angle R, because they're both 63. Okay, so now we need to identify the corresponding side lengths. So let's start with MN, this long side. What does that correspond to in the other triangle?
QT.
QT. What about the short side NP?
OQR.
QR. And the longest side, the hypotenuse, MP?
RT or TR.
RT. It doesn't matter. RT and TR are the same thing. Same name for the same, different names for the same thing. Okay, identify the pairs of congruent angles and corresponding sides. So we're doing the same thing here. So where do we start?
AB.
Let's start with the angles first. So congruent angles. So what's one pair of congruent angles? B and G. Perfect, because those are both 90 degrees. So angle B is congruent to angle G. What's our next pair of congruent angles?
A and H.
So angle A, what would be the measure of angle A? How do we find that?
90 minus 59.
It would be 90 minus 59, which is
C and H.
31.
C and
So what's the measure of angle J?
31.
31, same thing. So what two angles are congruent here?
A and J.
A and J. And then what's our last pair of congruent angles?
C and H.
Angle C and angle H. Okay, now we need to name the corresponding sides. So let's start with our hypotenuse. What are the two hypotenuses?
5.8 and 11.6.
Well, what are the names of them?
HJ and AC.
So CA corresponds to JH. What's another pair of corresponding sides? BC and HG. Perfect. Those are both the two smallest sides. So the smallest side corresponds to the smallest one. And then what's our last pair?
BA and GJ.
BA and GJ. Perfect. Okay, so next we have a similarity ratio, which is the ratio of the lengths of the corresponding sides of two similar polygons. The similarity ratio of ABC to DEF is, so we need to find what the ratio of this triangle to this one is. So in order to find that, we just take one leg. So let's take AB, which has a length of 3. And we need one leg from our bigger triangle, which would be 6. They're all 6, so we could pick any one. So our ratio is 3 to 6. How does this simplify?
2.5.
1 to 2. So our ratio here is 1 to 2. So now if we find the similarity ratio of DEF to ABC, we're going to start with the bigger triangle, which has the side length 6. What corresponds to 6? 3. So how do we simplify this?
2 to 1.
2 to 1. Ready for the next one? Okay, determine whether the polygons are similar. If so, write the similarity ratio and similarity statement. So in order to tell that they're similar, we need all the angles to be the same, and we need all the sides to have the same ratio. So are all the angles the same here?
No.
All of the angles of A, B, C, D, do they correspond to E, F, G, H?
No.
Why?
Because there's 4 and there's 9 and 6.
The angles.
Oh. Then
Yes. Why do you know? Why? They're all 90 degrees because they're both rectangles. So all of these angles are 90 degrees. So all of our angles are the same. So we have a check mark there. Now we need to make sure all the sides are in proportion. So we're going to compare the short side to the short side and the long side to the long side. So let's set up a ratio for 6 to 4. What does this simplify to? 3 to 2. Now let's set up a ratio of 9 to 6. What does this simplify to?
3 to 1. Or wait, no,
3 to 2. Alright, so do they have the same proportion?
Yes.
Yes. So are these triangles similar?
Yes.
Yes.
That's confusing.
So yes, they're similar. So our similarity statement is just saying that like this triangle is similar to that one. But we have to keep it in the same order. So if we start with angle A, so let's say rectangle ABCD is similar to what? Where would we have to start? EFGH. Perfect. So we just have to keep it in the same consecutive order. Any questions? Let's go to the next. Okay, so I set up. So the smaller side is going to be similar to the smaller side. So I set up the ratio from 6 to 4. Okay. The long side of the big rectangle is going to be similar to the long side of the small rectangle. So this will have the ratio of 9 to 6. Now we can simplify 6 to 4 because 2 goes into both of them. So it simplifies to 3 to 2. And we can simplify 9 to 6 because 3 goes into both of them. So 3 divided by 9 is 3. 6 divided by 3. Yeah. So we're just simplifying them. Yeah.
And if they're all the same when they're simplified, then it's
yes. So since this is the same as this, then they're proportional. And all their angles were, the corresponding angles were congruent. So yes, they're similar.
explain the ratio.
Okay, so step 1 is to identify the pairs of congruent angles, and step 2 is to compare the corresponding sides. So these are the 2 steps that we need to follow. So the next example, determine whether the polygons are similar. If so, write the similarity ratio and similarity statement. So what's step 1 to determine if they're similar?
Find angles.
Finding angles. So how do we find angles P and R?
You could subtract.
What type of triangle is PQR? Isosceles. So what do we know about P and R?
They're the same.
They're the same. So how do we find the measure of P and R? 180 minus 36, and then divide that by 2. So what's 180 minus 36?
144.
144. So then we take 144 and divide that by 2. And what do we get?
Wait, why do you divide it by 2?
Because there's 2 angles. So these 2 added together are 144, and they're the same. So we can just divide it by 2 to find out what each one is going to be. So each one of these is 72. We don't even need to find the other angles of STW because the first angle it gives us is 62. And that's not the same as any other angle in our first triangle. So are these triangles similar? No.
Can you go back up to the other side?
Okay, the next example. Determine if triangle JLM is similar to NPS. If so, write a similarity ratio and a similarity statement. So what's step 1? What do we need to do? Find the angles. If we know that angle M is 90 and angle N is 90, those 2 are congruent. We know that L, it doesn't tell us what measure it is, but it has 1 arc mark, and P has 1 arc mark, so those are congruent also. And then by the third angle theorem, we know that the third angle has to be congruent also. So J is going to be similar to, J is going to be congruent, the angle J is congruent to the angle S. So now that we know that the angles are congruent, we have to find if the sides have the same ratio. So which side is congruent to which?
M and N, S and L.
Okay. Let's,
What?
Ryan, what'd you say? What sides? So we need like a side.
Yeah, N and S and.
No.
N and
wow,
S.
my bad.
P
That
and
was
N
wrong.
and L.
What'd you say?
M and L and N and S.
No.
I'm gonna M
P, J, S, and no. L,
P,
P, M, N, J.
P and N and L and M
P and N
and L and M.
and L and M. Perfect. If we look at the picture,
Like what you wrote before.
so we said PN is similar to LM.
Oh, he has friends.
So what's the measure of PN?
24.
And what's the measure of LM?
45.
60. So our first ratio is 24 to 60.
Can we simplify that? Or
How do we simplify it? What number goes into both of them?
3?
Let's try 3. But 3 goes into both of them, so that works. So let's divide both of them by 3. 24 divided by 3 is,
8 to 20. We can divide this by 4.
and we can divide those by 4, so
2 to 5.
2 to 5. Perfect. So this is our similarity ratio. Now,
Leave it at that.
we need to see if the other sides have the same ratio too. So what's another pair of congruent sides?
M, J, and S.
NJ. What did you say?
I
M,
said M, J, and then S.
MJ and NS. Perfect. So MJ is 45 and NS is 18. So let's see if those have the same ratio.
You can do it by 9.
So we divide 9 into both of these. So 9 goes into 45.
5.
Oh, it's 5 to 2. It's
Two.
opposite.
But one thing that we didn't consider, we need to keep this consistent with this. So the first number, this one has to be from either the big one or the small one first. So PN is coming from the small triangle, right? So MJ, whatever comes here, has to come from the small triangle too. So we flip them. So this should be NS corresponds to MJ. Since we stated this one from small to big, this one needs to be small to big too.
Okay.
So now we have 18 to 45, which is
2 to 5.
2 to 5. And what's our last pair of sides we need to check?
30 and 75. J, L, and PS.
So we start with PS because PS is coming from the small triangle, and that corresponds to JL. So the length of PS is 30, and the length of
75.
JL is 75. So how do we simplify this?
5.
You do 15.
15 goes into both of them,
That'd be 2.
2 to 5. So since all of our ratios are the same, they're similar. What is our similarity ratio?
JLM is similar to NPS. Or PS.
So since we started with the small one, we need to start with the small one when saying our similarity statement. So we would say NPS is similar to JLM. And what's our ratio?
2 to 5.
2 to 5. We're going to go over this more on Monday.
Okay.
The first thing we need to do, since the question's asking for centimeters, we need to change all of our units to centimeters. So how many meters are in a centimeter? How many centimeters are in a meter? 100. So if we have a car that's 5 meters long, how many centimeters would that be? 500. And our car is 1.8 meters wide, so how many centimeters wide would it be? How many? 180 centimeters. So we know that these two cars are similar, so they're going to have the same ratio. So we can set our ratio up as 180 over 6.3. So we have the width of the racing car and the width of the model car. And that's going to be equal to the length of the racing car over the length of the model car. So it's important here that we keep it consistent. So we have the racing car on top and the model car on bottom. We need to have the racing car on top here and the model car on bottom here. So now how do we solve for x? We cross multiply. So we're going to multiply the x by 180, so we get 180x, and the 500 by 6.3. 3,150. So now what do we need to do? Divide 180. And what do we get for x? 17.5 what? Centimeters. So our model car is 17.5 centimeters long. Okay, let's go to our next example. We're going to do the same thing we just did. So a box car has the dimensions shown. A model of the box car is 1.25 inches wide. Find the length of the model to the nearest inch. So our box car, it's given to us in feet. So if our answer needs to be in inches, what do we need to do to get our feet into inches? Convert it. So how many inches are in a foot? 12. So what do we need to do to our box car? To the length of the box car. Multiply by 12. So what's 36.25 times 12? 435 inches. And our length is 9 feet, so we need to multiply that by 12. We get 108 inches. So now we can set up our proportion. What's going to be our first proportion that we have? Our first fraction? What is it? 1.25. And what's that equal to? Perfect. So if we have our box car on top here and the model on the bottom, we need to have our box car on top here and our model on the bottom. Now how do we solve for x? So we cross multiply. So we get 108x is equal to, what's 435 times 1.25? 543.75. So now we need to divide by 108. And what do we get for x? We get 5.03, but it's asking us to find the length of the model to the nearest inch, so we can just leave it as 5. So our x here is 5 inches. So in these, all we're doing is setting up the proportion and cross multiplying to solve for x. Ready for the next example? Determine whether the polygons are similar. If so, write the similarity ratio and a similarity statement. What are the two things we need for polygons to be similar?
Their corresponding angles are congruent,
Their corresponding angles are congruent,
and their corresponding side lengths are proportional.
and their corresponding side lengths are proportionate. So here we need, first step, corresponding angles to be congruent. Do we have two shapes that have congruent angles?
What do you say?
Do we have two shapes that have congruent angles?
No.
No. How do you know?
I don't know, it's kind of a guess. It's not both the same.
Is 70 the same as 90?
No.
No. So our corresponding angles are not congruent. So therefore, these two shapes are not similar. Ready for the next one? The ratio of a model's sailboat dimensions to the actual boat's dimensions is 1/30. If the length of the model is 10 inches, what is the length of the actual sailboat in feet? So we have the ratio of a model's sailboat's dimensions to the actual boat's dimensions. So what is the one referring to? The model or the sailboat? The model or the actual boat? The model. Right, because the model is obviously going to be smaller than the actual boat. And what's the 30 referring to? The actual boat. And it also says the ratio of a model's sailboat's dimensions. So it first says the model to the actual boat. So it starts off with the model. The first thing it says is model. So since the one is on top, it's going to be referring to the model. So the length of the model is 10 inches. How do we find the actual length of the sailboat? What's going to go on the bottom of our fraction here? X, because that's what we're trying to find. So what do we need to do to solve for x? Cross multiply. So we get x is equal to 300. 300 what? Inches. What's the question asking us for? Feet. So we need to change this inches to feet. What do we need to do? Divide by 12. So we get x is equal to 25 what? Feet. Any questions on this? All right, one last example. Tell whether the following statement is sometimes, always, or never true. Two equilateral triangles are similar. What are the two things we need for triangles to be similar? What are the two types of triangles it says we have here? Equilateral. What does it mean for triangles to be equilateral? They're equal on all their sides. What do the angles of an equilateral triangle have to be? 60. So all of these angles are going to be 60. So do we have corresponding angles that are congruent? Yes. So you can put a check mark there. No matter what two equilateral triangles we have, their corresponding angles will always be congruent because their corresponding angles are always 60. Their angles are always going to be 60. Let's give our small triangle side lengths. So what could be the side lengths of our triangle on the left? 3. So if one side's 3, they all have to be 3. What about our second triangle? What could be a side length there? 6. So if we set our small triangle to our big triangle and we made a proportion, we would have 3 to 6. What would this simplify to? 1 to 2. All of our sides are going to have the same proportion. So it works for that. Let's try something else. What's another side length we can make for all of our sides on our big triangle? Anything. It could be 9. What would be our proportion for one of the sides here? 3 to 9. If we simplified that, we would get 1 to 3. And all of our sides have the same proportion, 1 to 3. So no matter what two numbers we pick for these triangles, they'd always have the same proportion. So are two equilateral triangles always, sometimes, or never similar? Always.